welcome here.
Hold
Oh, I can stand here. Hello, welcome here. In this time with LLMs and security, automatic leak finding, it's much more important to find the errors in your code. And how to do this in Python might be with the scanner, but I'm sure Michael will tell us all about this.
Right, thank you for the introduction. Yes, people, welcome, my dear friends. It's again wonderful to be here at this great conference on this Saturday morning. And don't be afraid, I will not going to sell you anything. Recently I read a scientific paper showing that it has now been scientifically proven that heavy use of AI diminishes your ability to think for yourself at a pace never ever seen before in history. So I'm a bit afraid because this talk requires you to think critically. You need to think. If you're into security, you need to think for yourself. So I promise everyone in this room, I'm really happy that you're all here today, we'll learn something new, I promise. Because you will hear everything about my personal journey creating a Python security tool. One disclaimer, I will show some code and please do not try it at home. You will lose your friends and your loved ones. So be warned. We dive into is Python secure and why this kind of talk? What is assessed? So we need to be on the same plate to understand why I did what I did. So am I stupid? Why did I create such a tool? There are plenty. I dive in the key principles, some architecture things, and of course a demo thing. It worked today still, but yeah, it's always tricky. And of course, plenty of time for question discussion. I'll be here all day, maybe tomorrow. So who am I? I'm an independent architect for a very long time. I used to work as architect at several companies. I'm a FOSS advocate. I really preach for using, yeah, that was the last guy that I expected already.
Sorry,
no, but he knows the intro, so he knows who I am. So, welcome. So, please use, I advocate, use open source security tools for validating security. That's why I'm advocating for as long as I live. So, is Python secure? It's interpreted language. It's the #1 language for a very long time. Everybody can use it. Everybody does use it. It powers machine learning, AI nowadays. So why bother? Guido was not silly, so what do we think? Do we really need to check security and Python things? It's a scripting language. Who bothers? Now, let's dive in a moment. And think about it yourself. As I said at the beginning, Python code is not secure by default. Why? Most Python applications have access to your network, your file systems, your storage devices, your data, your phone. So Python code needs privileges, so it's not secure by default. You can do very, very nasty things with Python code. You can create malware with it, and so beware. Some simple things. It's a tech conference, so we need some code to feel happy, of course. This is a classic one. For already more than 25 years, still in the OWASP top 10. #3 in the 25 list. Validate, validate, sanitize. But it's hard, people, even in Python code. This administrator, yeah, maybe he's fired now or he was fired before. He left some script. If you're still using Windows, you can, yeah, he managed also something for that. And I use a lot of Python code, and I want to know what is in that code. I want to know if these kind of strange things are incorporated in models I use. Another silly example. You use something and you execute. Python has the ability to execute things on the fly. Not only with the simple exec, but there are more advanced ways to do it also. And what did somebody do? He obfuscated the string. And the string is, yeah, do whatever you want on the system where you are running. I want to know. This is Python malware 1.0. And it still happens today, every day. Be warned. The last example, dynamic imports. Who here is a Python programmer? Before I continue? Nice. Who here uses module imports and checks for dynamic model imports from others? At least one is awake.
Dynamic imports.
Yeah, and I say, don't trust it. You never know what you are importing, so be alarmed.
For what it's worth, the modules I do import dynamically, I also wrote myself. Now I am pretty.
Yeah. Yeah, that's correct. I never write test software for my own software because I do not make mistakes, so you're totally fine. But dynamic import is a great Python feature, but yeah, it's a source of real misery. And I use a lot of Python code of others because it's a language with batteries included. And that's great. It saves you a lot of time. But you need to know what you're using from others. And what helps for these kind of things? We're all a bit security minded, so yeah, you can check some vulnerability database. And yeah, the strange thing with vulnerability database, only a small fraction is reported because it takes a lot of effort and time to report that something is not correct in the module. And I want to find weaknesses, not only vulnerabilities. So the thing that really helps, you can of course do other things, place everything in a container, but we do a shift left. And shift left means look at the design and the architecture. But yeah, code does not lie. So if you look at the source code, maybe you can find if things are correct and there are execute statements or other strange things. So the thing that is really a proven method for this kind of things is using a SEST tool, and SEST is a static application security testing tool. Who now in this room uses this kind of tools on a daily basis for C code, Java code, or other things? Yeah, that's good.
Coverity.
Yeah. And of course, the beauty of this method, and it's a proven method, is that you do not execute the code, so it's totally safe. And something that you also hear within security is DAS, so dynamic application security testing, fuzzers. And typically you do that on web applications or imports or interface, those kind of things. But it's another thing. You need to do this also. It's cheap, it can be fast, especially before you use Python code of others. So I thought, I use those kind of things. I use a lot of Python the last 20 years, and I want to know, can you program? Is it secure enough for my use case? Because security is never black and white. So I checked, and yeah, I don't like black boxes. So I'm an open source guy. So I got really frustrated with the current open source and commercial SEST tools for Python. most tools are complex to use. When I want to try a module, I want just click, click, click and see what kind of weaknesses are in there. And most of those tools have a very complex type of commands with a lot of options. Yeah, in the past you could search Stack Overflow. Now you can ask AI, but you get the wrong answer. So using those kind of tools, yeah, it's not simple enough, at least for my use cases. And I use more code than I write, so it must be fast on code of others. And the things in the open source domain, yeah, there were not many. The commercial things, yeah, they are advertised as great solutions. But the truth is, they put the burden on you. You have to define all the rules for checking things. Yeah, I know what I want to check. There is a standard Python library with all kinds of constructs that I want to check, are they in the code? So why did I need to define my own rules? Yeah, it's not simple enough. So, frustrated, I want open source, transparent, I want to know what a tool does, I want to trust a tool. And I have simple requirements for such a SEST Python tool. Local first. I don't trust remote things. Period. Simple to use, quick to use, simple to extend. Sometimes I have some special use cases, and when I want to add something, it should not take 2 days or a week to add some functionality to an open source product. Of course, it must be transparent, good coverage of common weaknesses. So not all those fancy Python libraries as Django. No, only Python standard modules, libraries, things. And so limited scope, because testing on correctness of TLS certificate is something totally different than checking Python code. Checking web applications on sanitizer user input is something totally different than checking code on typical constructs that can cause weaknesses. So I searched and I searched and I searched, and no tool met my simple requirements. And what can you do? You can take an old open source SES tool and make it better. So I looked at those kind of things and I thought, no, this ain't gonna work. So what do? You think, I can do it better. I create something that is simple. So, yeah, and we all know that creating things can be fun, you learn a lot. I can recommend it really to everyone. It's a joy to do, at least it should be. I'm human, so I'm a bit lazy. And we all know 100% coverage of everything is not possible. So I use the Pareto principle. 20% what I do in program should cover 80% of the common weaknesses. Because those really advanced hacks in Python code, yeah, you can try to create something that covers everything, but yeah, then you lose 10 years of your life, and the majority of your things that you want to see is in the 80%. So I aimed for the 80% in the simple way. The most simple way to do that with Python is using abstract syntax tree. Who here is familiar with abstract syntax tree? Nice, yeah, technical conference, of course. So the way that works for people who did not raise their hands or are too shy, there is source code, Python, really easy to read. Normally it gets tokenized, and then it gets converted into an abstract syntax tree. The abstract syntax tree is converted to Python bytecode. So Python is not interpreted 100%, is also a bit compiled into Python bytecode. And Python has this nice, really nice module that you can use for this kind of things, the AST module. And when you use that module, you can convert source code directly into abstract syntax trees. Who here has ever played with those kind of things? Yeah, now, you know the documentation is a bit dated and not many play with it.
Yeah, there are subtle differences between Python versions. The tree is slightly different.
Yeah, so you need to know what you're doing and what you're checking, but it's a great way to analyze source code without compiling type of constructs you want to find. So I use that, and not only me, of course, because a lot of other Python SAS tools use the same method. So you have to have a good reason for not using this method for validating and scanning Python code. This piece is only a snapshot. If you convert that simple piece of source code, yeah, it is much longer in the abstract syntax tree. So, yeah, it's really nice, but it can get complex. So, what did I create? Weakness detection, of course. And weakness is something different than vulnerability. I call it weakness on purpose, because there are constructs as unzipping. It can be a weakness, it is a weakness, but does not have to be a vulnerability. Security is never black and white. I want to find weaknesses. And a vulnerability can be a threat, but it does not have to be a threat. And I want a clean overview of weaknesses in the things I use or import, whatever. Another thing that I have created is some complexity rating with security relevant statistics. If you have a large code base, you can see per file what the complexity rating is. That has some advantage from a security point of view. Who here is familiar with complexity ratings and source code, not only for Python? Yeah. What kind of metric do you use?
I know of the concept, I don't use the actual tooling for it.
Right. Yeah, I use the 1976 method, the Maccabee complexity formulas, but a simplified version. So you count in source code if-then statements, functions, those kind of things. And it gives a rather nice indication of the complexity of source code. And we all know from a security point of view, simple changes can have great effects if you're not totally aware of what you're doing. And from a security point of view, I want to know when I use code base of others, what am I using? Is this really under control? I also want to know what kind of models somebody uses. And the thing with model use is there are a lot. Really a lot. I think more than 800,000 on Python PI only. And the simple thing that you can do is, of course, check for known vulnerabilities. But yeah, as said before, it says something, but it's minor. But it was so easy to create this check that I could not resist it. Yeah, it's a bit of scope creep, but it's nice to play with it and to have it also in this tool. It's really simple. I will show it later, but yeah, I couldn't resist it, sorry. But mind, you hear a lot about S-bombs and those kind of things. It's all based off checking known vulnerabilities. The most kind of weaknesses in Python code or source code in general are never reported in those public repositories. So mind, check for weaknesses yourself. I want the things to be able to use in a quick way, so nice, fast overview. I know what I'm looking for. I don't want complex commands. I like browsers since 2002, so give me directly some browser view that I can click on. period. And in red, of course. The thing that bothers me also today with a lot of things that you import is that a lot of external libraries use remote analytics, telemetry, AI things, and I want to know because maybe you put a black hole into your code base by importing such a thing. Who knows is using some AWS library or an Azure library or whatever, OpenAI library, it's all the same shit. You import something, you buy a key, and you're screwed. The thing that you get, I call it egress detection, and egress detection is you're screwed forever. If you have this imported in your code, yeah, stop with security. It makes no sense at all. You need to know it. And this is a shift left way to detect it. So I look at the source code. Another way to do it is, of course, monitor all your network traffic, but it's a lot of work. Now, the best way to do it, look at the source code and try to find it. The way those kind of things, like telemetric servers, analytic servers, work is often you buy an API key, overpriced for OpenAI or DeepSeek, whatever. It's just one in it, you're screwed forever. And the rest, you never see things in the code. You never see what's happening. Why? This kind of modules do dynamic imports. The number 3 daily model that is most used on Python is Boto3. Who here is familiar with it? It's some AWS module. All your data is sent to them. Yeah, success. Implementing this kind of things, yeah, it was a bit of a struggle. I searched for research papers, I looked at others, but there is no decent SaaS tool that has this. But I'm a security guy, I thought, yeah, this should be possible. So I really like to discuss during lunch or the rest of the day with you.
Okay. All right.
Yeah, hello. Hello and welcome to this talk, a brief introduction into resilient data backup. Let's just start. Who am I? My name is Andreas Rogge. I'm a full-time Barreos developer, a long-term user of Barreos and previously the other product that existed before. Originally I have been a systems administrator, but that's some time ago. So where do I work? I work at Barreos GmbH & Co. KG, which basically funds the Barreos project and explains why I'm talking about backup and not about backup products, because I'm super biased, because I'm developing a backup product. Nevertheless, that company provides services around Barreos, which is backup software like binary packages, long-term support, customer support, trainings, partnerships, whatever, funded development. If you want to do anything with Barreos, give us a call. We can probably help.
Maybe a short break until everyone's seated.
Sure.
Please sit down. Chairs here. Yes, yeah.
Yeah. You missed the advertising block.
They should have given you a larger room.
I explicitly said so on the registration, but never mind. Okay, so as everybody has either seen or missed the advertising, we will start with an overview. So what I'm going to talk about is basically three things. First things first, what is the purpose of backup at all? Why do we do that? What are the best practices to actually do a backup that you can probably restore from? And then the really interesting part is how to make that resilient and what is resiliency at all. So first things first, what is the purpose of backup? And I think we can basically sum that up to retain the capability to respond in event of data loss. So in case you lose data, you don't want to be helpless, you want to have some capability to react on that and maybe get your data back or continue whatever you were doing. To ensure business continuity, which sounds pretty enterprisey, but nevertheless, you may have continuity issues if at home, for example, your NAS dies with your spouse's photos on that, and you are not able to restore that, you might also have some kind of continuity problem. So,
Never seen that. No, never.
so basically, backup is your last line of defense against data loss. So, but how do we lose data? Any ideas what is the most common cause for data loss?
Human error. Yeah.
Human error. Who has never accidentally deleted a file? Who has used DD as a command? Who already mixed up source and destination when? So obviously human error.
No, I did worse. I was trying to demonstrate that I protected a server once against rm-rf/. and I showed my colleague by doing it on the mail server.
Mm-hmm.
I had not protected as well as I thought.
So, second, two human error ideas?
Mechanical error.
Sorry?
Mechanical error.
Yeah, so hardware or system failure. Yeah, everybody had that, something broke, failed, or whatever. Next to that, ideas?
Malicious software.
No, actually not. Software bugs. So actually, unintentional maliciousness in software is worse than actual intentional maliciousness in software. But it's the runner-up, so the next thing that happens is malware. And then, of course, we have external influences. So in German that works pretty well because it's externe Einflüsse, which is like water running into your data center, which is an external influence, or fire or whatever. You get the idea? And external influences. And last but not least, loss and theft, which is actually the least experienced problem of data loss, according to some statistics I looked into. Practical example, what can happen or how can you lose data? Something that we have seen during daily business was somebody had bought a really, really expensive S3 compatible storage system with object locking to store some warranty relevant records, mostly photos and invoices and stuff like that. So of course that was stored on an appliance with a RAID 6 storage pool, so you can lose up to 2 disks. And of course that was replicated to a second appliance, just to be sure. And because having 2 of these next to each other is not sufficient, we have a third appliance in another location. So that's absolutely safe, nothing can happen. The brochure of the large US storage vendor says, this system makes backup unnecessary. Problem is, the object lock policy was set to 10 months instead of 10 years. So, back to human error, obviously. So, best practices for backup. What are proven methods? What should you do to get a backup or backup system that you can actually trust? So, first things first, 3-2-1 rule. Who knows the 3-2-1 rule? That is definitely too few. So at least if you don't take anything else from here, this one. So you're supposed to have at least 3 replicas of your data. That, depending on the source, but usually, originally, that includes the original data. You should have 2 copies on different media. Different media types, maybe, that's up to debate, but definitely not all copies on the same storage medium. And at least one of these replicas should be in an off-site remote location, just to be sure. So that's pretty easy to make that happen. In theory, you could say, okay, I have a RAID 1 system, so that's 2 replicas. And now I rsync to an external USB hard drive that I bring to my neighbor. That would mean you already did the 3-to-1 rule. But yeah, it's
the external influences that affect
Yes.
might affect your neighbor.
So let's say the 3-to-1 rule is a great starting point, but the example we just saw, they did most of that, if not all of that. So it's a good starting point, it is required, but it's not sufficient. So what else do we have to do?
Test.
Yes, that's later. So first things first, you have to plan your RPO. So you have a recovery point objective. How often you want to take a backup? Because you have to make sure that this works over time. Because you break something now and you want to go back to the past. So you have to decide back to which points in time in the past do you want to go. So the question is, which amount of data loss can you tolerate? And that absolutely depends on what kind of data you're having. Often that's proportional to the amount of changing data, but not always. So for example, to come back to the photo archive, if you do a backup once a week and you only clean up your SD cards, I don't know, every quarter, that's not a problem, because if you lose the system, you restore the set from a week ago, and then you get everything you hadn't there back from your SD card. If you maybe do, I don't know, a magazine, and you are editing the title page, and it's due for delivery tomorrow, maybe backing up once a day is not really sufficient, because if you lose it and you have to deliver it, that's a problem. So that's something to think about. Other things, maybe you don't need backup at all. Think, for example, a package tracking database, so DHL or something like that, that has super fast rotating information, and you need a way to restore that, but probably not some backup from days ago, because that information is not relevant anymore. Which brings us to planning of retention times, because now you have a backup for a specific point in time. But you can't keep these indefinitely unless you have indefinite storage. In that case, just come to me and tell me where, and we will work something out. So basically, the question is, how long do you have to keep your backups? And the question is, can you lose data without noticing it? Often, that is proportional to the amount of times you access that data. So for example, if you have documented how to renew the certificates on your web server, most people look at that once a year or every 2 years, depending on how long your certificate is. Or, I don't know, maybe some data you need for your tax returns. Usually once a year. If it gets lost in between, it's gone. You probably won't notice. So now we know how often we want to have a backup and how long we want to keep it. But can we actually restore that? So we have to validate and test the system. Do we actually back up data at all? Or for some reason things stop working because somebody disabled the cron job? So you need to check that you actually match the RPO that you defined, that you are actually backing up. Is the scope of what you are backing up correct? Do you back up all the files that you actually need? How do you check that? Can you actually restore? Did you try to restore the data? So who ever tested a backup? That's also too few of you. So who tested a backup or a restore last month? Great. Within the last week? Great job. Is the restored data actually usable?
No.
Who looked? So if you try to restore and the restore job was successful, do you actually look at the data? Do you verify that this actually works? And obviously you should verify that regularly, because if you have a backup and you meet everything, RPOs, retention times, but you can't restore, it's worthless. Next thing is automation. So you want to automate. You want to automate the backup. You want to automate the monitoring of your backup. If possible, you also want to automate the testing of your restores, and you want to automate the removal of outdated backups. So who does backup sorry. Who backs up data manually? Who has a process that somewhere between your system and the offsite you have a manual step? So, do you monitor your backup system? Great. And do you test automatically? One guy, great. Who deletes old backups manually by selecting the folder and pressing delete? Did you listen to what I said about the most obvious cause of data loss? Just saying. Next thing is cataloging. That is not too obvious at first, but you probably want a list of the backups you actually have. Especially if they are offsite. You don't want to drive like 50 kilometers, getting some drive, and you have no idea what's on that. And you don't know if you actually needed to go there, and that will help you. Probably you also want an index of the backup contents. So before you go to the offsite or you insert a tape or whatever, you actually know if the file you are looking for is on that. In some cases, it also makes sense to have a catalog that says where is that backup actually located. If you have multiple sites or multiple people getting things off-site and back on-site, it's sometimes not obvious where is that medium currently. So depending on things, you may need that. If you don't need it, it may still take a bit of time to catalog that, and it will save time and nerves in case of disaster. What you also want is good processes, which sounds pretty weird at first, but you want to make sure that ad hoc changes are inconvenient. So nobody just ad hoc deactivates some backup because it's a problem without somebody noticing. You probably want to require documentation, and that sounds a lot hand-wavy and stuff like that, but basically what that says is maybe put everything in Git, which also allows you to ensure traceability, so you know who did some change in the configuration 6 months ago. Probably it was you. And that enables the ability to actually review the configuration regularly. And if you did all of that, you probably now have some backup system that actually works, that stores data, that allows you to retrieve it again. Everything is fine, right? Which brings us to resilience. So resilience is, I think that's Wikipedia or something like that, the ability of a technical system to avoid complete failure during partial outages. Which means in case of a backup system, even if something goes wrong horribly, you still want to somehow be able to recover your data. But how do we do that? So resilient backup basically just means you have to make sure the backup data is available to retain availability. You want to retain integrity somehow. And probably you also want to ensure authenticity. So the data that you restore is actually what you wanted to have and not something else. Which brings us to the extension of the 3-2-1 rule, which is the 3-2-1-1-0 rule. Who knows that one? So, of course, 3-2-1, 3 replicas, 2 different medias, and one of those offsite. And then we have 1 immutable copy. So one of these copies should be immutable, obviously not the primary one, and 0 verification failures. So if you test and you have a problem, You don't document it and open a ticket, you go fix it. Which is, again, a nice starting point, pretty good rule of thumb to get things better than with just the 3-to-1 rule. But of course, what do I have to consider to make things like that work? So one thing is you want to have something offsite. So you want a secure and safe offsite. We already had that with a neighbor where water may be a problem that hits your neighbor and you. So distance seems to be one thing. Far enough, not too far away. Because if it's too far away, you have a problem with accessibility. You want sufficient separation, which is a bit hard. We will come to that. So maybe a data center, maybe a service provider. Problematic. Practical example again. You run your application in one of the major clouds. So, I don't know, Google, Amazon, I don't care. Yeah, maybe. And of course you have the primary backup at the same location, which is fine. Then you have a second backup at another location, so you have your offsite backup. Sadly, the credit card that was on file for payment got blocked because you ordered something in, I don't know, China, Temu or something like that, which led to your cloud account being locked. So your application is no longer available and you can't restore. So the question is, what do I have to foresee and how do I foresee what things can happen? And how do I lose access to my data that is not only technical, but also maybe organizational or things you just didn't think about. That's always something that can happen. You probably want to plan a recovery time objective, which means how quickly do I have to make things work again. This usually varies a lot, like the RPO, where sometimes you have to do it like hourly or half hourly, and sometimes it's like, okay, I do it once a week. Some services and things need to be back up really quick, some not. And that's always a cost-benefit analysis. So, of course, you can make it so that you can restore everything at a fingertip, like you restore and it's there in, I don't know, 5 minutes. Usually not cost effective. So that's the hard part. And you have to consider dependencies. Because if you have not just lost one single thing, but a lot of things, you have an order in which you can recover. So if you have a system that depends on 3 other systems, you can't recover that quicker than you can recover the 3 other systems. And you have to check feasibility to make sure that this actually works. Other practical example, a customer I talked to not too long ago, they have a central file server in their location and they want to back that up to an offsite, which is nice. Little data movement, small incrementals, only incrementals because they did the full already, some external S3 storage. But over time, the data volume grew to 500 terabytes. Their one connection is 1 gigabit. How long does it take to do a full restore?
Months?
49 days. I don't know what RPO they have planned, but I'm pretty sure it's less than 49 days. Another thing that is a bit problematic is encryption. Of course, we don't want to do no encryption, and I don't want to encourage you to not encrypt. but it's oftentimes a problem of confidentiality versus availability. Because if you want to recover a backup that has been encrypted, you need the key material to decrypt it. And that must be available. And not only that, you have to be able to link it to the backup data. So if every user has its own key, do you trust your user to have that key in case of a restore? Do you have a second copy of that key somewhere, stored safely? How can you retrieve it? If you can retrieve it, do you know which jobs it's associated with? So that basically has the chance to worsen your RTO, because you have more things to consider during restore, and that makes things, let's say, unpleasant. But then again, you don't want to do no encryption, so a bit hard to say. Next thing is tamper resistance. So you want to protect against deletion, obviously, to preserve availability. And you want to protect against modification. So that usually works pretty well if you put media offline. Nobody is going to do anything to them. It's a good idea to write protect media, if that's possible, or if it's really critical to find media that you can write only once. One thing that always comes in mind, and that's discussed a lot, is digital signatures, which is totally nice, but doesn't help you, because if the signature does not fit, you know it's not the right data, but you don't have the data. So, yeah, so far I think for the data itself. Then access control. So if you have some backup system and you run that, please, please, please do not connect that to your single sign-on system. If you really have to connect it to your single sign-on system, please make sure that users from SSO get minimal privileges possible. And if you can, make sure privileged access requires two-factor authentication. So, last question for the day. Who can delete one or more of his backups without using two-factor authentication? Which is normal, but maybe if the data is critical, you want to think about that again. So that brings me to the conclusion, which is people make mistakes. So you should have a tested backup. And you should have that even if something goes very, very wrong. Thank you very much.
Question.
Wait for the microphone, please.
Oh, yeah.
So I actually wrote a blog post about my backup setup recently, and one of the things I was concerned about is resistance to ransomware. So if my server gets compromised, can that malicious actor somehow get access to either my on-site or my remote backups? Using Borg, but that's immaterial. So what I was looking for was a solution that would not store any credentials on the server itself. Is that something you consider, or is that something?
So one of the main things which is, so ransomware is how I actually personally came up with a two-factor authentication to your backup system. Because if somebody compromises your work laptop and you can just SSH into your backup system and RM-RF read mail really fast all your data, that's probably not great. So security requirements you have for your backup data is usually one level higher than for the actual production system, which means you should never be able to connect from your production system to the backup system, but only the other way around. A lot of the free software that we have today is not designed in that way, which, yeah, it's up for debate, but it's hard to do. Also getting things tamper-proof in a way that you can't break it yourself, because the malicious actor doesn't have to be ransomware. It can just be a rogue systems administrator, for example. So if you have something a bit more complicated, maybe you want other people doing the offsite than the people who do the backup, so that process is not in the hands of a single person. But it's really hard, and especially for the ransom case, a lot of the backup and archiving systems that we have are not designed to resist that. Most of the time, something gets put onto that afterwards, like, okay, we can somehow detect here if files were encrypted and stuff like that. But I'm not too fond of that. But a lot of commercial vendors at least try to do that. I don't know if that actually helps.
So but then what's left? Air gapping and warm tapes. So maybe only the really physical secure thing is air gapping and maybe warm tapes and stuff like that, right?
So if you have a medium that you trust that will not be overwritten, because either you just have a physical write protect, or you have, like Stefan said, tapes that you can write only once. You know that this will not be overwritten, especially in the case of LTO tapes. The attack surface is pretty small because it's all in the firmware of the drive. But then again, you are never reusing your tapes, so there we are back at square one, where we have to ask ourselves if that is actually feasible. Because of course you can do everything, but it's always a cost and benefit trade-off you're looking at.
Oh, yeah.
So thanks. I was wondering, does your software have a plugin system that you could add other storage systems into? The reason I'm asking is because I'm working on a decentralized storage system. Could we plug it into Barrios, and could then people start using it?
You absolutely can come see me later.
The added benefit would be because our decentralized storage system actually only allows you to put stuff on there and never allow you to delete it. So you don't have the capability to delete it yourself, which would solve the previous problem that we're talking about.
Unless that system gets compromised.
Yeah, but then we have a bigger problem.
Any further questions? Then I would like to thank the speaker again.
Dank u.
Thank you.